Hey, it's Mr. Lum, and we're going to be going on with some Science 10 stuff, and we're going to be talking about salts. So, salt is an ionic compound. Um, Now, much of the world's surface is covered in water, and most of that water is salt. Now, that salt, it happens to be sodium chloride, but there are many different types of salts, and we're going to be talking about quite a few of those. So first off, what is a salt? Uh, in a neutralization reaction, it's when a positive ion from a base and a negative ion from an acid combine to form a salt. So a salt essentially is an ionic compound formed during a neutralization reaction of an acid and a base. So a neutralization reaction is when an acid and base react. So for example, you could have like an acid like this, HCl, and a base like this, NaOH, and it produces a type of salt. And again, it is the positive ion from a base. In other words, it is going to be the positive ion from the base is going to be Na, so it'll be Na, and it's going to be the negative ion from the acid. So Cl is the negative ion, so it'll be NaCl, and then water, which is just H2O. So this is salt, NaCl. Now, just because that's the type of salt that we're familiar with, there are many other types of salt. So say if we had a different type of acid like hydrofluoric acid, HF, plus potassium hydroxide, KOH. So again, the metal or the positive ion from the base, K, the negative ion from the acid, F, and then water. So potassium fluoride, that is also a type of salt. It's an ionic compound formed from a neutralization reaction. So NaCl, KF, they're both different types of salts. You can put the video on pause so that you can record some of these notes right here, and then we can move on. But the list goes on. It could be a little bit more than that. So let's think of another type of acid that we learned about. So sulfuric acid, H2SO4, and we'll talk about another base. We'll use the same base. We'll use NaOH. Okay. So we take that positive ion from the base, Na, so and we take that negative ion from the acid, which is SO4, and water. Now I made a mistake right here because even when you're writing this stuff, you still have to swap and drop. So Na, if you look on your periodic table, is +1. If you look on the back of your periodic table, on the polyatomic ion sheet, SO4 is 2-. So when you swap and drop, it becomes Na2SO4. So I need to write a 2 right there. It's Na2SO4. Now, Na2SO4, this is also a type of salt. So KF, NaCl, Na2SO4, those are all types of salts. Now, what are some of the different ways we can make salts? One way that we can make a salt is through that neutralization reaction that we just did. So a neutralization reaction is when you combine an acid and a base, and they kind of cancel each other out, and they make water and salt. And all of those reactions I did on the previous slide, those were all neutralization reactions. Now there's a few other ways that we can make salts as well. So the next way that we can make a salt is taking an acid and adding it to a carbonate. And what a carbonate is something that ends with CO3. You can find carbonate on the polyatomic ion sheet on the back of your periodic table, but carbonates neutralize acids. Later on, when you're like, say if you're taking chemistry 12, you'll learn that carbonates are a type of base, but they neutralize acids as well. And a carbonate, well, we could take a look at this one right here. So we have sulfuric acid right here, H2SO4. We have a type of carbonate. In this case, we have calcium carbonate, which ends with that CO3. And again, if you treat carbonate kind of like it's a base, because it kind of is a base, that we're going to take the positive ion from that base, or we're going to take the positive ion from that carbonate, so that calcium, and combine it with the negative ion from the acid, that SO4, and that produces calcium sulfate. Okay, now calcium happens to be Ca2+, if you look on your periodic table, and sulfate happens to be SO4 2-. So they cancel out nicely so that there is no subscripts there. And then it produces water, and then it produces this other kind of weird thing of carbon dioxide. And that just happens to be something that carbonates often do. And I think I have my numbering messed up right here. But the other way that we can make salt is adding acid to metal. So here we have an acid. We just have like a metal. In this case, we have magnesium. And whenever you add acids to metal, a very common thing that it produces is hydrogen gas. So you'll see a lot of bubbling and it'll produce hydrogen gas. In the previous one, it'll also produce a gas, but usually that gas is carbon dioxide, which is not flammable, and hydrogen gas is flammable. So when you take an acid plus metal, HCl plus magnesium right here, it produces that hydrogen gas. Remember, it has that 2 there because hydrogen is part of that diatomic 7, or Humph-Brickel, as some people say. And then this right here is your salt. Why is it a salt? Because it's an ionic compound. That's magnesium chloride. So ionic compounds are salts, and that's one way we can make one. So we're going to be talking about a few other little things, and one of them is oxides. So an oxide is a compound that has oxygen in it, and there are 2 different types of oxides, and hopefully you can get it. There's something called metal oxides, and then non-metal oxides. And so we're going to be talking about what happens if you take a metal oxide and what did they produce, and what does a non-metal oxide produce. So first one is a metal oxide. So a metal oxide is a compound that has a metal that is combined with oxygen. So a metal oxide becomes a base when they react with water. So here's my general example of this would be right here, a metal plus oxygen. X just stands for any metal. So a metal plus oxygen is a metal oxide. And when that is thrown into some water, it's going to be producing a base right there. So an example of that, we can say, let's imagine we have sodium. Sodium is a metal. Sodium oxide, like that. Now, and we throw that in water, and hopefully you've caught the mistake right now. Oxygen is 2-, sodium is 1+, so when you swap and drop, it should be Na2O. When you throw that into water, it's going to be producing a base. And if you remember, bases end with OH. So that's going to be producing NaOH. Just kind of like that. Okay. Now, if you're being good, you should balance it and do something like that. Okay. So that is an example of a metal oxide. And when you add it to water, it becomes a base. Another example, let's do something different then. Instead of like Na2O, we'll have something like MgO. Now, for MgO, do I need to have subscripts? Hopefully you figured out the answer is no. Magnesium is 2+, oxygen is 2-. When you combine them, MgO. And then we're going to add that to water. I should have subscripted this one. We're going to add that to H2O, and it's going to be producing MgOH like that. Now, hopefully you caught the mistake again, because magnesium is 2+ and OH is 1-, and so when you swap and drop, it should be MgOH2, right like that. Okay. We have to balance it, and hopefully you realize that it's already balanced. You have 1 magnesium, 1 magnesium, you have 2 oxygens, 2 oxygens, you have 2 hydrogens. Okay, so again, metal oxide produces a base, ends with OH. Now, that's going to be a little bit different than a non-metal oxide. So a non-metal oxide is a chemical compound that contains a non-metal and it combines with oxygen. A non-metal oxide becomes an acid. So in other words, they do the complete opposite. They don't make a base. A non-metal oxide becomes an acid when they react with water. Here's a general example right here. So an example of a non-metal oxide you might see is carbon dioxide. And when I'm in class, I'll do this demonstration here. But say if you take carbon dioxide and you add it to some water, it's going to produce an acid. When you make your acid, you just kind of like mush everything together, making sure that usually your hydrogens go first. Okay. And this right here is carbonic acid. CO3 is carbonate. Carbonate becomes an ic acid. So this is carbonic acid. Like that. So where do these non-metal oxides come from? Well, not the best places sometimes. So non-metal oxides often form from like burning fossil fuels, different types of emissions. So you can get nitrogen oxides, which could be forming like nitrous acid or nitric acid. You can have like sulfur dioxides. So if you had something like sulfur dioxide, SO2, that's a 2. And if you have SO2, and let me do that better. If you had SO2 and it's released into the atmosphere, it's going to go and mix with a cloud. And what are clouds made of? They're made out of water. So sulfur dioxide mixes with a cloud and makes H2SO3. And if you know the name of this, great. If you don't, this is sulfite. So hydrogen sulfite and ites become OS acids, or in other words, sulfurous acid. And this is a huge contributor to acid rain. So, and if you put a lot of sulfur dioxides into the atmosphere, it does produce a lot of, or had the potential to produce acid rain. Now, what's so bad about acid rain? If I'm being honest, acid rain isn't going to affect a human being that much. You're covered with dead skin and dead hair, and so it's not going to be super detrimental. But things that are will be affected are things like fish, which have to live in that water. They have these mucous membranes, fish are kind of slimy, and they have it kind of breaks down some of that that protective layer on the outside of a fish, and they have to live in that, while we can often just kind of go inside. And so it'll kill fish quite easily. It can hurt plants. They have to, again, live in it. And then a lot of structural things that we put together. So if you're making acid rain, which is like H2SO3, sulfurous acid, many of the things that we carve, like this statue right here, it's often carved with things like marble. And marble is just a carbonate containing CO3. And we learned earlier that carbonates will react with acids. And so you get like things like when acid rain hits things made out of carbonate, it'll start to wear it down. Here is like you can see a lot of the stuff that is kind of wearing off of this Buddha statue right here. So these are some of the negative effects of acid rain right here. Anyways, hopefully you can do the worksheets that are associated with this, and I'll see you next time.